Welcome to a brand new video created for anyone who's trying to learn and master the command line. I'm not sure what we're going to name it, but it's probably going to be something like command line for data science routines or I don't know, but we're going to come back to the name later. And I want to put a special emphasis on data analytics and common data science workflow. Now, you don't need to know anything about data science to be able to practice what you learn from this series. It's still going to be the same thing, shell commands. They're always going to be helpful if you're trying to do any kind of work, whether it's programming, software engineering, data science, data analytics, right? But if you have to wrangle with CSV using pandas or R in the past, then maybe you've been frustrated. And what I hope to do with this series is to just add a new tool to your repertoire of other skills and complement what you already do with the great pandas library and R and all the other numerical libraries. And if you're looking for a job and have graduated from a bootcamp with R and Python as the primary skill set, then adding command line mastery will greatly help your chances in the interview. So to make it even more relatable and familiar to anyone who's working with data analytics, data scientists, I'll be using primarily CSVs in this tutorial. So we're going to be using shell commands, but against the CSV. And I'm going to make sure that CSV is freely available. In fact, I'm going to give you the link right now. So this is it. I'm also going to put a URL in the description, but this is the dataset. And all of the code of the analysis that we're doing, all of this will be on my GitHub, and the link will also be in the description. So if you have any trouble downloading it, leave a comment. I'll reach out to help you. Now, before we get into it, I want to ask for a favor. I've only started actively creating videos in the last 2-3 weeks, and I need any help I can get. So if you enjoy the content, believe somebody on the same journey as you can benefit from it, please share it on social media, consider subscribing. And if I want to make it big, you get the bragging rights to say that you were a follower before I became mainstream. So I also get to send you a sticker, okay? And one quick teaser, I asked this question to one of the Facebook groups that I'm in, and this is what I said. I said, what's more impactful to a data scientist beyond R and Python? And I said, I argued that it's mastery with the command line. You can do so much with shell commands in fractions of a second, what may take you 6 to 10 lines of Python code to achieve. And bash is also super fast, especially on huge data. LC, word count, we're going to learn about that, -L, lines, sales, and then here you have the head -5 that shows you the first 5. And then here's we're using some cut, we're using some sort. But here, this is a way to achieve, with a CSV of 397,000 rows of data, what is the fastest way to tabulate, find the top 20 countries? And this is just one line of shell, right? Like just running one line of shell, you get the answer. So it's not just efficient, sometimes it's necessary. And it seems like there's a little bit of interest. There are people who are sharing and were asking for a more drawn out video on that based on what I see in the comment section. So I thought maybe there's an opportunity to create something more full-fledged, maybe from start to finish, about how I use shell and what are the most common shell commands when it comes to working with CSV files, data files, or just doing any kind of data wrangling in general. We start off by acquiring the data. We need a data set that isn't too small. Let me show you what we have here, and let me maybe just read a little bit about this. It says that typically e-commerce data sets are proprietary, consequently hard to find among publicly available data. And this is a data set that is containing actual transactions from 2010 till 2011. The data set is maintained on the site. And this is a transnational data set which contains all the transactions occurring between 1st to 9th of December 2010-2011. Sells a lot of gift, so it's a kind of a gift e-commerce, all right? Many customers of the company are also wholesalers. And if you take a look at the data, it's about 46 megabytes. How many unique values? There's the invoice number, stock number, 8 columns. So if you want to pause the video, head over to the kaggle.com or head over to the UCI machine learning repository, whichever you prefer, and just click on that download button. So I'm going to give you this link. I'm also going to just open this link up just to show you. This is also where you can download that. All right, search for online retail, click on repository, do a search, and you should get exactly the same data set here. Once you've downloaded that, just store them somewhere. Just store them on the downloads folder if you want to. Doesn't matter. And you want to also make sure that you have a compatible shell to follow along this entire video. So we're going to be using this thing called the command shell, or just shell for short. And what shell actually means, this is the shell that you're looking at right now. So if I print working directory, I'm in the downloads folder, nothing fancy. But this shell is a program on your computer that runs other programs on your behalf. Now those other programs can do things as simple as telling us the time, or as complex as parallelizing some long-running machine learning scripts in a map-reduced pattern, or as long as they obey a few simple rules, the shell can run them without having to know what language the scripts are written in, or how they do what they do. If you're a Mac or Linux user, you can just proceed with the rest of the series using the default shell that ships with it. Usually this is going to be the bash or the Z shell, the GSH. So this is G shell. If you do a bash, this is the bash. You can use G shell, you can use bash, it's up to you. But for Windows users, please pause the video, do a quick Google search on activating Windows subsystem for Linux. So this is how it's Windows subsystem for Linux. So do a quick Google search on that, look at how to activate that, look at how to install that. You may have to restart your computer at least once, and once you've done that, you can proceed the rest of the video using bash in your command prompt or your PowerShell, but just as long as it's on bash. And this is the assumption I'm going to make for the rest of this video, is that we're just going to do our practice in bash. Alright, let's warm up by asking the shell to print out current time. This could be useful for when we need to maybe automate our work and save some file names with a timestamp so they don't conflict with existing files, which is actually quite common, right? A pretty common practice, at least in where I work. It's a pretty common practice with automated logs or periodic pre-scheduled tasks. We want to create new file names, and the file names contain the timestamp of the time that the file is created. So let's maybe try and do that. So to clear out the screen, I'll just say clear. Clear basically clears out all my screen, and I can let's say print the current time. What do we do here? We say date. When you say date, it's going to give you the current time and date. In this format, it's going to say that this is a Sunday, this is the date, this is the time, and then I'm in this time zone, this is the year. If you don't want to see all of that, you think it's too much, too verbose, you can actually just specify a format as well. You can say date, and you can say plus, and here I will have the month slash date slash year. If I don't want a slash, I can have the dash, I can have the dash like this, or I can have the slash. I can also have the year up front. So year, that's the percentage Y and percentage M and percentage D. I can also have this, or I can just have this as slashes. That's the format. If you've done any kind of programming in R or in Python, this should come very familiar. This should come across as something quite familiar to you. And this is the same thing. You specify the format, you put a plus sign before the format, and you press enter, and that would just print out the date in that format. So speaking of the scenario that I mentioned above, how you would use it is probably creating something like we call a shell variable. So let me clear the screen again. And if you need to slow down the video, absolutely do so. So open up a terminal and just follow it line by line. Every time you see me punch something, just pause the video a little bit. Make sure you practice that. Make sure you get familiar with the concept before you move on. All right. So, and I think that's the only way to learn. Truly, I don't even think that's the best way to learn. I just think that's the only way to learn. When it comes to the command line and stuff like that, you can watch as much video as you want. You're never really gonna learn it unless you really force some of this into your muscle memory. So let me clear the screen again. So to create a shell variable, it's just kind of like a variable, but in the shell, within the shell that in which they are defined or set. So if you close this shell and you reopen that, it's gonna be gone, right? So this is a shell variable. Let's call it logsdir. Logsdir. This is the key, and then this is the value. You can set this value to be anything. You can have this to be equals to 100, and then when you want to print that out, you can just say echo, and you can put a $sign, and then you just have to say logsdir. So that's how you print out the shell variable, right? So echo logsdir, print that out, it prints out 100. So echo is kind of just print that out, right? So this is a very simple way of creating a shell variable, but you can combine that with the date knowledge. So for example, I can go ahead and do something like logsdir, and instead of doing this, I'm actually going to say evaluate. So this is again where I'm going to use the $ bracket syntax. So every time you see the $ bracket syntax, just like this here. So this is kind of saying that evaluate this first, and then whatever value that is, just print that back into the logsdir and save that into a shell variable named logsdir. And here we're just going to use the same date command that we've seen. So we just say date, and we can pass an option as well. So what do we want here? We just have to pass a format. So in this case here, I can put something like, let's say, day, month, year. If I want a 4-digit year, so 2022, then I'll put a capital Y. If I just want 2 digits, then just a regular Y, or lowercase y rather. If I do that now and I print echo, to just repeat the same command that you've printed out in your shell, you can just press the up button. So when you press the up button, it goes up and it kind of just walk you through your history of all the commands that you've written. So you don't have to rewrite the whole thing, you just have to go up, down like this and scroll through your history before hitting enter. So let me do that. And now I have the echo. So I can now say if I want to create the file name of this maintenance log, let's say I have a maintenance directory. So let me just write that out. So I said I want to have this, and I want to say something like logistics, for example, or shipping. So shipping, within shipping, I have a ton of logs, so I can have logs within that. Now, this is where I want to print out the CSV, right? I want to have this as part of a CSV name, so I'm going to have something like this. I know I'm going to have a CSV later, but this is where I can put the logsdir. So logsdir. If you want this to be part of the file name, you just have to hit enter. If you want this to be part of the directory, so dir stands for directory in this case, you can just put another one and maybe have out.csv and just print that out. So now I'm just constructing this file name so I can later on take the data that I want and store this into this out.csv. This seems simple, but you want to watch out for a couple of things. And the first thing is you want to watch out that there is no spaces between the equal signs. So if you do something like logs entry, and now you put something like equal, and you type something in there, you're actually going to get an error. In fact, I don't even need to run that because in my shell, it would just tell me that this is not going to run. It shows me a red color here knowing that it won't run. If I change this to a equal, then the red color just goes away. But let me show you again. If I do something like this, it will not work. All right, hit enter, it says command not found logs entry. And the reason for that is if you put a space, now the shell is going to try to attempt to interpret this as a command. And it's going to try to run this command. Does it find a command? No, it doesn't find a command. So it's going to tell you command not found. So this thing is just plainly not going to work. So you want to make sure that you create shell variable. There is no spaces between or around the equal sign. All right, there are two main types of variables in the shell. The first one is called the environment variables. So two main types of variables. The first one is called environment variables, and the second one is called shell variables. And environment variables are global variables inherited by all shells and the corresponding child processes. So this is useful for when you want to set a password, let's say a password to your database, and you want, every time you boot up your computer, you don't want to recreate this variable, you just want it to be there, available to all shells. And so that's probably something you want to do. And for example, some of us use Git or GitHub version control systems. And so the configuration of that is very common to set that up as environment variables as well. Which Git do we refer to? What is the Git username? What is the Git password? All of those things, right? Shell variables, on the other hand, are available within the shell in which they are defined or set. They are commonly used to store temporary data and are automatically destroyed once the shell session is terminated. So the data that you downloaded earlier from kaggle or from UCI, that should already be available on your machine. So let's move to that location and then unzip that. To move to that location, for me, it's going to be on the downloads folder. So I can just change the directory and to go to downloads. That's where I'm already at, so won't do anything. But for you, just move into the downloads folder, and you can do that by using cd command, and you specify the path to that location. So if your default download location is going to be on your desktop, then you want to change this to a desktop, and your path is going to look very different. But try and figure that out before you move on. So find where your files are downloaded, move to that location using cd. Cd stands for change directory, and then you want to unzip that. So where do you want to unzip that? That's up to you. But I'm going to actually unzip this to a directory on my desktop. So I need to create that directory first. So the command to create a directory is called mkdir, and I'm going to just create desktop, and I'm going to say cl for ds. So cl for ds is just going to be command line for data science. I may change the title later on, but for now, I just want to create that. mkdir, let me put that in the notes as well. So the second one is a note here. So this is called make directory. So I'm making a directory on my desktop. I'm saying that if I go to my desktop, there is no such folder at the moment. So I'm saying that, okay, go ahead, create a directory or create a folder and name it cl for ds. So if I hit enter now, this is not gonna work because desktop itself doesn't exist within this path of downloads folder. So I want to specify the actual path. But if you're doing this from a different location, then you have to change that. So mkdir, and then you will specify where the directory is created, and you pass in a path to that. If you want to create in the current directory, all you need to do is to just take away all of this and just call it cl for ds. This will just create a directory called cl for ds within your downloads folder, within where your current folder is at. This is the downloads, right? So it's going to create a cl for ds within downloads. And that is just not what I want. So I'm going to go ahead and remove that. So I'm going to say remove, and -r say remove recursively, which means delete a folder. And I'm going to say cl for ds, going to delete that. Instead, what I want to do is I want to say go to my desktop instead and create a directory there called cl for ds. So let me run that. And then now let me move the file that I downloaded. So when you first download this from kaggle, it's gonna probably be called archive.zip. At least that's what it looks like on my directory. So your mileage may vary here, but you want to find the file that you just downloaded off kaggle, the big e-commerce dataset that we talk about. All right. For me, it's called retail.zip. So I'm gonna say move retail.zip, and I'm gonna move that to my desktop. So I'm gonna say this. So what this is gonna do is to move. mv stands for move. So let me go into my notes again, and I say mv move. Right. Move this zip file onto my desktop cl4ds. So move to this location. So try to resist the temptation to ever use the mouse. So if you can, if you need to slow down, just slow down the video, right? But try to have all of this done within the terminal line if you can. So move retail.zip, you hit that, and now we can now move to desktop cl4ds. So we can change directory to this directory and look and try to work with this zip file. So you can say move to desktop cl4ds. Once you move into the directory, downloads is going to change, right? But just to show you what I mean by that, if I print my current working directory, pwd stands for print working directory. So if I add that to my notes first, print working directory, move that back up. Now if I run cd desktop cl4ds, now if I run pwd again, I'm in that new directory. So let me change directory back to downloads again. Print working directory is now back in downloads, right? So I can actually do this. And if you need to do this a couple of times just to get yourself familiar with it, go ahead and definitely do that. So cd and then go back to cl4ds. But what you can also do is you can use the and sign to change another command. So you can say change directory and then do something after the first command here has been executed. So for example, I can say change directory, and then once I'm in here, go ahead and unzip the file. So I can say unzip, and what do I name it earlier? Retail.zip, right? So I can say retail.zip. I can do that. If you want to, you can have this as separate commands. You can first change directory, and then you can say unzip retail.zip. You don't have to do them in one go, but just to show you how it looks like. So I want to pack in as much knowledge as I can onto this one video. So I'm going to also talk about that. So this is the way to tell shell to execute the second command, the second command only if the first command is successful. This is the logical AND operator. So as you may have guessed, you can also do the OR operator. We haven't get to that phase yet, but this is the logical AND operator that tells you that logical AND. So it says operate the second command after the first has successfully execute, right? So change directory, and if that is successful, go ahead unzip the file. So let me do that, and now it's a archive retail.zip. Now it's inflating. Now I have online retail.csv. Of course, as you get more familiar with the command line, you could have also done a lot of this in just one line of code. For example, you could have gone back to your downloads folder. So let me go back to the downloads folder. So let me print working directory, this downloads. Actually, if you know my current directory from the shell prompt itself. But now that I'm in downloads, I could have said unzip -d and pass in a location. I can call this a demo location, wherever it is on my computer, and then I just have to pass in the retail.zip. So this could have been the desktop demo files or temp files. This could have just been one line of command. So this is saying that unzip this file into this directory, and if this directory doesn't exist, then go ahead and create that. So in other words, create the directory first called this. If it doesn't exist, and then extract the archive, extract everything, the content within this zip to this directory. So this is really the beauty of learning the command line. It has a pretty gentle learning curve, but once you've got better at it, you just find new ways to do things with just greater efficiency. And that one line of code is just so much better than using a mouse to drag and drop things around, right-clicking to unzip, and finding a location through a drop-down menu. Most importantly, allows you to work in a way that is predictable through code that can be version controlled, and to work even on remote servers where you kind of have mouse drivers to operate a graphical user interface. So it makes you a much more valued member on the team. And even though you could have done everything on that one-liner, I choose to do it in a laborious way, in a more step-by-step way for another reason. And the reason is to show you all of these commands here. Let me change all of this back to the desktop. And I'm going to say cl4ds, right? That's what I created. And if I just print out ls right now, I could see that it has been unzipped. So I see the online retail.csv, I see the retail.zip. By now, if I don't need the retail.zip anymore, I could just go ahead and delete that. But if I want to, I could also just keep it there, right? To remove something, you just have to say rm and retail.zip, the name of the file. If this is a directory, you just add a -r to say recursively. Recursively says delete all the contents within the directory and then delete the directory itself. So recursively delete everything and then delete the directory itself. This is not a directory, this is just a file, so I don't even need that. So let me just run that, and then let me just confirm that that has worked. ls again. Oh, now I only have one file, online retail.csv. So when I actually work, I probably work a lot faster, but to do it in this slow way kind of give me the opportunity to show you some of the most common operations in the command line. You may even want to just pause the video and just practice this until you're familiar enough with this routine. I haven't actually added ls in there, so let me just say ls. ls just lists the files, so list everything in there. And we've also seen rm, so let's put remove here. But the commands that you see here, cd, ls, mkdir, mv, pwd, rm, if you can actually pick over the shoulder of a senior developer doing his work in a command line, you see that these are some of the most common operations. And if I have to add something else, it's probably going to be cp. cp basically means copy. So to show you what it looks like, so say I have ls again, I only have this one file, right? And I'm gonna start working on this file, and you know that you're gonna make changes to that file, you're gonna make modifications to the file, but you want to preserve the original file so you don't have to go back to Kaggle and re-download the original ones. So how do we do that? Well, we can just make a copy of that. And so we can do something like copy and online retail.csv and give it a name here. And what do we want to copy? We can call it retail original without any modification, and we can just say .csv. And so if we do that, if we list, now we have two files. Basically just copy one file onto another one, and the new one will have the name retail-original. So now when we perform our operations on online retail, we don't have to worry about accidentally making modifications and then not able to go back to it unless we download it again. And before we start to actually work on this more seriously, I want to also maybe give you a quick tip, is that you can actually use the -v option. -v stands for verbose, and it works by being verbose about the action that you're doing. So for example, you can say something like mv, or you can say something like cp again. So let me do cp again, but I can say something like -v, and now let me just call it retail original2.csv, and if we print that, it's just gonna give us a verbose message about what it just done. And same thing here, I can use rm. Well, you've seen that I can say rm retail-original to.csv, but I can also say a -v. So adding a -v just make it verbose, and you just sort of print out a message for each file that it deletes in this case. So if I do that, it says remove retail original.-2.csv. Maybe in the future you probably wouldn't do this anymore, but while you're in the learning mode itself, it's kind of probably I don't know if it's going to be helpful, but I just want to present that to you. If you want to use the -v just to have a visual message, a visual clue feedback about what you're doing, what your commands are doing, you can use the -v. And this also works with moving files as well. So if you want to say move and you want to say -v and you want to do the same thing, moving a file from one directory to another location, you can also put the -v in there. So spend some time and get used to all of these commands that you just seen there, and use the -v if you need to. If you don't need to, then just leave it out of your command. But at the end of it, just make sure that you have the online retail.csv. You don't actually even need that, so I'm probably gonna just remove that, but let me just keep it there for now. And for the remaining part of this video, we're just gonna work on this CSV file. I'm gonna show you how to look at the number of rows, the number of columns, how do you take that and create a simple table, and do all kind of fun stuff just using the command line without even opening our Python. So last call to action, make sure you try to practice the commands that you see here. At least you shouldn't be intimidated by the terminal line itself. And once you feel like you're pretty comfortable, add that into your data science toolkit. So every time you work with data and stuff like that, you don't just have Python R. You know that if you need to do something, you can using just the command line, and it'll give you a lot more speed, a lot more performance, and it just make you more versatile. Let me clear my screen now, and I'll see you in the next section. Alright, to make sure that we have more data to work with, which will come in handy for some of the demo later, some of the exercises that we do. You can put in some more extra CSV from your machine. So if you have some CSV laying around on your machine, go ahead and do that. I've done that with some of my data sets already that I've scrapped using Beautiful Soap and Selenium, and I put them in there. And to do that, you can use the CP command. We spoke about that. So CP command is right up here. This is CP command. So CP stands for copy. You can also use the mv command, the move command. That's also something we looked at earlier. So mv. And I have a few files that are scrapped using Beautiful Soap. So I actually just want to copy that in, and I say CP, and I can just pass in the path. For example, I have something in here, and I have some projects, and I have some scrape data, and these are like a wine e-commerce store, and I have that, and I'm gonna just copy that from this location. Maybe you may have a different location, so you want to change that, right? And then I'm gonna say copy that into this current directory. So the current directory, you can put a dot here. So the dot here is a special name and refers to the current directory, so which you get from the prompt shell, which is this, right? Or just typing pwd again. If you're not sure, or where am I again? Pwd prints the working directory, and I'm in the desktop CL4DS, and so dot would refer to this location. So what this is saying is to copy this and put it into the current location, right? I'm not gonna do that because I've done that already, so I'm just gonna remove all of this. And since I've done that already, if I show you my file, I have a couple of CSV here laying around as well. But I'm primarily going to be using online retail.csv because this is the CSV that allows you to just follow along the video from the link that I mentioned in the beginning of the video. And so what we do is we're going to try and maybe take a quick peek at this data. It's something very common to data scientists, right? We have some data set. We want to maybe find out, hey, how many rows are there? How many columns are there? These are common things that we want to take a look at. So to do that, the first thing you want to learn, let me actually add a note at the bottom. Exploratory commands, and this is just word count, right? So let's go back to word count, and this is how we do it. Is we say wc and we paste in what is it that we want to count. WC returns either the number of words, the bytes, or the number of lines. If you want to only get the number of lines, you can do something like -l. So I would say WC-L online retail.csv, and I would just press enter, and it would tell me how many rows are there in the CSV. So -L stands for lines, alright? So this command returns the number of lines in the CSV, which is the number of rows in the CSV. This is not very different from how you would do it in pandas. In pandas, you would probably have something like something like df equals to pd.readcsv, and then you have your link, you have the URL in here, and once you've done that, you probably do something like df.shape, and it would return a tuple of two values. So you take this and you find the first value. I think something like this, 0, like the first value will be the row, right? Second value will be the column. And in R, you would do something like data.frame, or maybe you start from read CSV, and then you have your data in there, and then once you have that, you say something like end row, and you find the data frame itself and see how many rows are there. But if you really want to speed up this workflow, then just learn how to do that in the shell, right? It allows you to just quickly pick at the number of rows this data contains without actually having to open up or launch R or Python or run a full-blown Jupyter notebook as a process. All right. So again, WC-L and then the name of the CSV. If you do not specify the -L, what you see is you say online retail.csv, and it's going to return 3 different values that refers to the number of words, the number of bytes, and the number of lines. So you can also have them as like, okay, I want just the number of words, right? Number of words there. And if you just want to count the number of bytes, you can just say bytes, C. All right. So C basically the characters, number of characters in there. So number of characters, number of words, and then number of lines. So you can see it this way, right? Lines, words, number of characters, or bytes. In fact, this command is even more powerful and even more helpful if you have a ton of CSV file and you want to just quickly take a look at the number of lines in each one of them. Let me introduce you to another concept called the wildcard. So you can do something like WC-L, and then you can put a asterisk.csv. And what this would do is it would try to expand this first. It will expand this to match every other thing that has an ending of CSV. So notes.md is going to skip because it doesn't end with the .csv extension, but online retail, that's going to match. Readmine is going to match. So this is the same as just typing it out all manually. Just typing it out, typing it out, typing it out, all of this manually, right? So asterisk.csv, and using this wildcard to specify a set of files all at once, all together, right? So the most commonly used wildcard is just this one, just an asterisk. So let's run that. And now it's going to give us, okay, so there are this amount of lines in online retail, 92 lines in readmine.csv. This is just a copy of that, so it's going to be the same. 62 lines in whitewine.csv, 193 in wine.csv, and a total. So that's pretty cool. Give you all of that and then give you a total. Another thing that data scientists like to do is to just take a quick peek at the data, right? Just take a peek at it, maybe the first 6 rows, the last 6 rows. And in R and in Python, this is a very common routine as well. You have the .head or the .hill equivalent for each one of either using Python or either using R. So because this is such a common routine, you probably want to learn that as well. And the way you do that is you say head, and this -n takes a number, -n, and you put the name of the CSV. So you want to give a number like 5, for example, and it show you the first 5 rows of the CSV itself. So you see, okay, I have a header, and then I have the 5-day wine for home pack, 821 South Marlboro Sauvignon Blanc, America's Kiwis down under wine pack, and this one, California Chardonnay. I don't know. I don't drink wine. All right. So head and 5. Sometimes you see in demo, you'll see this being short formed to this, and it will still work the same way. So you see people using it interchangeably, but if you want to be more explicit, want to be more clear, then I would probably encourage you to stick to this format. And same thing here, you could also say till, and let me just change this white wine to something like online retail, because that's the data that you have. So let me say online retail.csv, run that, and now I have that. So these are the last 5 rows of the data. So I have 581,587. And let's actually take a look at that first, because I want to know what they are referring to. So head dash, I'm going to just take a look at the first row because that's the header row. So this refers to the invoice number. So you can see that one invoice could contain multiple items. So all of these items, so somebody, who is somebody? This customer ID. This customer from the country France check out with this invoice number and have bought a ton of things. Bought a few pack of 20 Space Boys napkins, aprons, Dolly Girl, cutlery, and bathroom spot, baking set, right? And how many of them did he buy? Or maybe did she buy? 12, 6, 4, 4, 3. And what is the date of those purchases? On the same time, at the same time. So they bought at the same time, and what is the unit price of that? And what is the customer ID? So you see that. And so these are the last 5 rows of the data. So if somebody asks you, if your boss comes in and asks you, hey, how many how many rows of data do we have? How would you answer the question? You want to think about that question a little bit more, because if you just do something like wc-l and you say online retail.csv, your answer is not going to be exactly correct because you actually included the header row itself. So you want to take that and you want to minus the header row. All right. So 541,000 rows of data, 910 minus 1, that's 541,000 rows of data, 909. So that's the WC, the word counter. All right. So you can use the word count. And let me make a quick note of that. So those are the options. Let's also go ahead and add the head and tail. And you can also chain these commands using something called the pipe operator or the pipe character, right? And the pipe character looks something like this. This is above your enter sign. So if you want to look for your return sign or the enter sign, look for it on your keyboard. And then above the keyboard, above the enter sign, there is this pipe. And it's called a pipe character because it does look like a pipe, right? Plumbing and piping and pipe. So I don't know if it does actually looks like a pipe, but okay. The pipe connects the standard output of the process from the left and to the standard input of the process to the right. What I mean by that is I could actually do something like, let's go back up to this one. So this one actually just prints the first line, right? It says head. How many lines of this CSV do you actually want? I said I only want one. Okay, so that's that. But I can take the input, I can take this as input to another process. Right, so let me show you what I mean by that, right? Hit on the pipe character. It says run this command. Whatever the output of this command is, in this case would be this. Whatever the output is, take that and use it as a input, as a standard input to the process in here. All right, in here. So let's try and just say word count the number of, let's say, characters. Why not? So let's do that. It says 83. So there are 83 characters. If you count 1, 2, 3, 4, 5, all the way up to the end. Y, you have 83 of them. So it connects the standard output of whatever that is returned here. It takes that and then it passes this on as a standard input to the process on the right. More informally, it kind of looks like it's just copying the output of this, whatever is being printed out, and it feeds it to the next program. Hopefully it's an adequate enough analogy, but really what it's doing is that take the output of this, take that, pass it as input into the second, into the whatever is on the right of the pipe operator, pipe character. So we're going to be using that quite a bit. So I want to add a note here as well. That's the pipe character. So maybe add a pipe character. And while we're here, let's also go and format that a little bit. While we're here, let's go and format that a little bit. Now let's talk about the cut command. So let's put a command here because we're going to use this anyway. The cut command is a command for cutting out the sections from each line of the files and writing the result to a standard output. So the standard output is whatever is being printed here, or you could use that and then you can pipe it to another process, right? Now it can be used to cut parts of the line by either byte position or by character and by field. And I almost never really have to use the byte option, which is the -b option. So it will look like something like this. It will look like -b. But I was almost never in a situation where I had to use the -b to sort of cut by bytes, maybe in the future, but most of the time though, I would cut by character or by field. How do I cut by character? I could say -c. So for example, I could cut 134 and I could pass in the data and I can say online retail.csv. Let me show you what I mean by that. And I don't want to print out the whole thing, right? So I just want to maybe just see the first few rows of data. So I'm going to just say something like head and I'm going to say, let's say the first 4 rows. That's good enough. And so what this is going to do, let me just show you what head would do first. Head n4 online retail.csv. This is going to give you the invoice number, and here is going to give you the number here. But when I'm saying cut by characters, what I'm saying is take the first, the third, and the fourth. So this is the first, then second, third, then fourth. So I skip n, go into VO. 5 skip 3, get into 6 3, and that is what it's doing, right? So cut does that. Well, let me clear my screen. But what's more helpful than actually cutting like single characters like that is probably to just cut the whole thing out. So you can say cut and then say 129, and you do it like this. And so it would say, okay, there's 1, 2, 3, 4, 5, 6, 7, 8, 9. So in this case, probably what you want is actually 1, 2, 3, 4, 5, 6. So probably 6. And now that would just give you invoice, but now it's gonna be cut off. But that's one thing you can do, right? Just to cut the first few. Here it's saying to cut the first 6 characters, and then I pipe that into the head. So I'm only going to see the 4. I don't want to print out the whole thing because otherwise this is massive. This is 500,000 rows of data. So it really makes no sense to want to print out the whole thing. You can also just leave it incomplete. For example, you can say 1, 2, something. And that would just cut from the first character till the end. So if I say 3, 2, and then we just say cut the third character to the end. You can also do the opposite. You can also say what about like nothing to 9. So cut from the beginning, the starting position, all the way to the 9th character. You can also do that. So there are a lot of flexibility about how you want to do things here. Say this one from a 7th character all the way to the end. And because we keep doing this pipe operator, I feel like what we could do actually is to maybe create a subset of the data and name it something else like a CSV or something that we can just use, and we don't have to keep piping this head and tail. So actually let's go back into our notes there, and I want to just add some comments here really quickly. So we have the C for characters, and you can use something like -C 1 to 5. You can do something like -C, and you can do something like 6, 8, 9. You could also do something like -C and something to 11, right? So that's also an option. So these are the examples we see, and just keep there for quick reference. Another thing that I'm gonna introduce you right now is this redirection. So it looks like this. This is just a shell redirection. And let's take a quick look at what it does, right? So hopping back in here, suppose I want to take the first few rows of this CSV and just keep them into a smaller CSV, and I don't have to keep piping the head and tail, right? I just want a temporary CSV that holds maybe the first 7 rows, for example. So how do I do that? Now if I do it -n 6 or 7, and I say something like online retail.csv, that's going to show the first 7 rows of the CSV. And what I want to do here is I want to say take this and redirect them to a file, and this file, it doesn't exist yet, but I can give it a name. I could call it retail sample, or I don't know, red sample, so we don't have to type the full name out, it's too long. Red sample, and that we just create a CSV called red sample and take the first 7 rows and then redirect the output of that into the CSV. So let me just run that now. If I show you, now I have the red sample. You want to be careful whenever you use this operation though, because red sample, if it already had any content, it will now be deleted permanently, and this output will then be used to recreate that. So you don't actually want to have that. And sometimes you don't actually want this even. What you want to do is to append to red sample. So the difference is subtle, but let me show you an example. If I want to take also the last 3 rows of the data, so I want to say till n3 of online retail, I want to do that. And I want to actually take this and append into red sample, meaning don't replace red sample with the output of this, instead append to that. How would I do that? Well, you use the attach operator. So you do it like this. All right. This is the attach operator, and this attached to a file, this appends to a file, and it doesn't replace the file. So add a quick command. And we can say red sample.csv. Of course, we didn't spell it correctly, so it's complaining here. So just give it a correct name here. Done. And now if you want to just print out the content of red sample, you can just say cat. Cat basically means concatenate. So we can say red sample.csv. And now you see the first 7 plus the last 10. So do we have that in our comments? We don't, so I guess let's just add that somewhere in here. Concatenate print content of a file. So if this file is huge, you don't actually want to use cat because it's going to print out the entire thing. If you have something like 500, what do we have? 500,000 rows of data, 550 over 1,000 rows of data. You don't want to actually say cat and print out the whole thing. So what's more sensible is to actually just take a look at the subset of that. Kind of like what you do in data science. You don't actually want to print the entire data frame. If your data frame is something like a massive, 2 million rows of data, you don't want to print the whole thing out. You just want to take a look at a subset of data. Let's go back in here and let's clear the screen. So let's go back to cut. Now, data scientists, they don't have to cut characters out of a file as often. I don't imagine so. So one of the more interesting usage of cut is actually to just use the fill option. How you write the code is -f, and -f operates by the fill. It says cut the fill. So you have 11 fields, for example, in a CSV with 11 columns. You say take the 6th field, meaning the 6th column, and take the 10th field, which is the 10th column. And you can say take the first field and -f1, right? So this is the fill option. So even though C option is quite useful, but it's only useful for like fixed length lines. So for example, if you're trying to take this and you're trying to take 1 to 6, and you're trying to get people's first name, for example, the thing is that there are people with longer first name and shorter first name. So if you don't have like a fixed length, then you're not really getting what you want, right? You're only always gonna get the first 6 letters. And if you have a, let's say, a membership number, and you're always gonna be fixed length on NRIC number or identification card, that could work. But even then, if you're using a CSV file, I tend to just default to the -f using the field. So I say I just want this field. I have 5 columns. I want the first column and the last column. That's more common for my use cases. So datasets containing things like item names, e-commerce companies, item prices, etc., they don't have fixed length lines, and therefore I don't find myself using the -d as often. I use the F option a lot more. How do we use that? So the -f usually go along with the -d. So the -d says delimiter. So let me actually go in the comment section and add all the way D for delimiter. So what is the file delimited by? Is it a comma separated file? Is it a tab separated file? Is it by spaces? What is it, right? So this could be things like tabs, comma, spaces, or whatever, right? It's quite flexible for that. And then you have the F flag, which is for field number. So this is how you use it concurrently. So let me show you an example, and then maybe I can elaborate on that. So in our CSV file, what does the CSV stands for? Comma separated value. CSV stands for comma separated value. So we know that the -d should be a comma. We know we want to separate that by comma. So if you have a semicolon, then you put dash semicolon, right? But I'm going to put comma because that's what we separated by. And then I can take the second column, or I can take the third column, and this is where I use the -f. If you did not specify any delimiter, the default value for that is tab. So cut uses tab as the default field delimiter, right? Default, right? Just to make sure it's clear on that. And now that you know my fields are separated by comma, then take the 7th field and return that back to me. So I can say red sample, which is the one that we just created earlier ago, and I can just do that and it will return that to me. So let me do that, and it will just return customer ID. What about it? Return the country. It wouldn't make a difference if you have it stick together like -f8. You could also have that. It would be the same thing. You could have -f space 8. It would be the same thing. Same thing here. You can also have the dash. You can also have the -d and then put a comma and then -f8. So you can also do that. It would be the same thing. So every time you want to cut a field, you want to specify, if your file is not separated by tabs, then you want to specify what is it, and that is using D, which stands for delimiter, right? So in this case here, it's separated by comma. So you say cut -d delimited by comma, and then -f8, which take the 8th field. And I feel like some of you may already observe that there is a caveat here, is that if the previous columns contain a comma in its value, you get a second half of the value. So this is not going to work really well. So for example, if my data looks like this, right? If my data looks like I have super type, and I put 8, and I have 300,000 employees, and then finally I have Indonesia. So this is going to be a problem, because if you separate it by the comma, what happened here is that you're going to take, let's say you try and take the 3rd field, you're expecting 1, 2, 3, you're expecting this value, but you're only going to get 300. And if you take the 4th value, you're expecting 1, 2, 3, 4, you're going to expect Indonesia, but you're actually getting only 0, 0, 0. So if you see CSV like that, first thing is that this CSV is pretty ill-formed, it's pretty badly formatted, but that still may exist, right? In the future, I'll show you how to use AWK org to sort of serve as an alternative, but right now I don't have time to go into that. We'll try and keep the video beginner friendly, easy to get started on, and we're not going to look at org at all, right? But in a future video, probably show you a more robust solution to this problem. For now, we just have to assume that we don't have colleagues that hate us and actively want to make our work life miserable, all right? So combining that with the redirection that you've learned earlier, let's work on the first scenario. Suppose your manager comes to you and asks you to do something simple, or maybe in his mind it's simple. He asks you to do this. He said, can you maybe export a CSV containing a list of customers along with invoice. Actually, let's close the nerd tree. Much better. Along with invoice, ID. Let's just keep it that, right? So boss comes to you and say, give me a CSV containing a list of all the customers along with the invoice ID. So this is a fairly common request. So how would you do that? And I'll give you maybe 1 or 2 minutes. You want to pause the video, try and think for yourself. And I'll give you a big hint is that you want to use the cut scenario that we mentioned about. And if you don't know which of the columns refer to that, and which column refer to the invoice ID, you want to use the head command to just take a look at the first row so that you know what the headers look like, and then from there try and write the cut command and try to pause the video. I'm not going to show you the answer until you try to solve this on your own, and then you can resume the video once you try. So I hope you tried, but let's take a look at the first line of the data, right? So we say n1 and we say online retail.csv. We don't need to count the word count, we just need to do that. And so what do we want here? We want to have the invoice number because that's requested by the manager. So manager said, hey, invoice number, that's that. And maybe the customer ID. So that's I know there's 8 columns, so this is a 7 column. So I want to first and a 7 column. So how do I do a first 7 column? So you just cut -d. What is it separated by? Comma. So let's put a comma. And then what do we want? The field. Which field do you want? I want the first field and the 7th field. So I can do something like 1,7. And then I just have to pass in the name here. So instead of doing online retail, I could just do something like red sample. But if you want to, you can also just do online retail.csv. And the boss wants a CSV. So what do you do here? How do you take this and export that to another CSV? You learned about that before. Well, that's gonna be the redirection, right? So say take this, output of that goes into a file called customers.txt or customer.csv or whatever you want. And if you print cat customers.csv, the one that you just created, you get all the results. But obviously this is too much. I'm gonna remove the file. So customers.csv, and then I'm gonna clear the screen. So RM stands for remove. You learned that already in here. And that's how you do it. So it's going back here. DD to delete. But let's just add a quick comment as well. That you can have something like -f. So you can specify multiple fields in one go. So 3, 2, 3, 5, I guess, right? Let's go back up. Now let's talk about sort. Just like when you're starting out learning Python or R for data analytics, you learn sort and ordering fairly early. And for good reason, they're universally useful. You have to use sort to take maybe the top 10 salesperson of the year, or to take the bottom 5 worst performing election years, etc. So in shell, sort is just sort. Sort is just gonna be like sort, that's that. And it sorts the contents of a text file line by line. And there are 3 rules for sorting. So the first one is line starting with a number will appear before line starting with a letter. So if I go in here and let me add a comment here, and let's say I have Samuel and I have 01 Samuel and I have Samuel. So line starting with a number will appear before line starting with a letter. So in this case here, this line would appear if you run sort, then this line is going to be bumped to the top, and then the next rule is that line starting with a letter that appears earlier in the alphabet will appear before line starting with a letter that appears later in the alphabet. So this one goes without saying. So let's say I have Teresa. So S and T, which one comes first? S comes first. So S will be bumped to before Teresa. Alright? So we could take this, we could yank, and we move it up. And then the last rule is that line starting with an uppercase will appear before line starting with the same letter in lowercase. So in this case here, there is a capital S, there's a lowercase s. Which one should come first? Well, the rule says that the letters that starting with an uppercase will come before that. So in this case here, this is correct. So that's kind of the 3 rules. So line starting with a number appear before line starting with a letter. So number comes before letter, and then capital case before lowercase, and finally the ordering in the alphabet. So S comes before T, A comes before B, so on. Alright. So let's start from the most useless operation to the most useful ones. So sort, for example, how do we run sort? Let's go back up here. Sort has a -o option, which says something like, I want to sort, and let me show you what it looks like. If I just print red sample, I believe, right? Okay, that's that. I could do something like sort red sample.csv, and you say sort red sample.csv, you press enter, and this is going to sort. So it's going to sort from here, it's going to compare, okay, 536, 365, that's going to be smaller than this. It should come before that, and you order that, right? And one big difference here is you realize that invoice, the capital I, has been bumped all the way to the bottom. And why is that? Well, because of the rule earlier that says that number should come before the letters. So 5 will come, and then invoice will be at the bottom. Compare that to at the top, where the original data looks like this, invoice number and the first row, and then this. So you can sort them very quickly. If I want to take this data and I want to redirect them into something like sort.csv, I can do that by just doing what you've seen before. So sort take this, the output of that, move that into sorted.csv, alright? But turns out there is an O flag that allows you to do something similar than -O, and you can say sorted.csv. This is exactly the same thing. So sort -O stands for output, I think. So O, that option, just output that into sorted.csv. So it's a sort red sample and then pass that in. Honestly, I don't really see why I'm gonna use that. I just prefer to just sort them and then I just use the redirection. It's functionally the same. There is no advantages. One is not quicker than the other. Okay, so that's the most useless option. Let's move up the useless to useful scale a little bit. The next thing I want to talk about is the -R option. So -R, right? So you can say sort -R. And sort -R allows you to, let me show you what I mean by that. If I just run redsample.csv, R stands for reverse. So -R sorts the input file in reverse order. So by default, it switched the sort from ascending to descending order. So basically from Z to A instead of A to Z. All right. So let's run that and take a look at what it is. And now you see the invoice and then 87878765. Right. So you see that now it's in descending order. And the reason it's not high up on the usefulness scale is that you can actually work around this in many scenarios. And for example, even by just instead of taking the head top 10, you can take the tail and take the last 10. But then sort also sort of sort it amongst these 10 different lines. So I guess that's that. If the order within those 10 lines don't matter, that you really just want to look at the top 10 customers by their lifetime value, and you don't really care whether it's gonna be within the order of that, doesn't really matter. You just want the top 10, then you can use head and tail. You don't really need to worry about the reverse order, but I guess that's there. So it's not entirely not useful, but it's also, it could be situationally useful, so it's kind of higher up. But what I find myself using a lot more is the -U option. So I can also sort -U. Don't worry about all of this stuff because I'm gonna add the comments in here and give you a few practices where you get to practice that on your own. So I'm gonna just say sort here first because that's what we're talking about right now. Let's add a backtick. We say O, output, and we have R for reverse. But now I want to talk about the U, which is kind of like unique. So the -U option sort and remove duplicates. So very, very helpful. At least in my experience, it's very, very helpful, especially when we get into the scenarios that I'll give you later. So I'll give you some scenarios and I'll ask you to use the things that you learn and try and solve some of these quizzes and puzzles, right? So how would you use -U? Well, anytime you need a unique, you need to remove duplicates before you start sorting. That's when you use it. So in this case here, if I say U and then I say R and I say red sample, try and see if I run online retail, and I would just want to count that online retail.csv, and I want to just count WC-L. I don't even need them to be in reverse. I just want to sort them unique. Okay, if I don't do the sort and instead just print the content, right, you see that there is the difference here. Is that if I just print all the contents, how many lines are there? 541,910. But if I do a sort and I say -U, what it's going to do? It's going to actually take the duplicates and remove them. So no more duplicates, and then it's going to count them because of the WCL here. And you see that there's a difference in here. Okay, so that's what sort is doing. And now that this data set is sorted, you can either maybe again use the redirection and redirect them to a sorted data set if you want to, right? Not going to worry about that now. But I would say at the very top of the usefulness scale from O, R, U, these are not incredibly common, but they could be useful. You just need to be aware of them. You need to know them. If you need to search it out, Stack Overflow them, you'll find example code to help you solve your problems. But what I feel could be really useful to you is the K and the N. This one lets you sort by a column number. So sort by certain column, a specific column. So that's useful. I mean, you can just from the name itself, you can tell, okay, sort by a specific column. That's exactly what I want. That's exactly what I would like to do on a CSV file, right? And the other one that is also pretty nice is N. This one sort numerically. What is sort numerically? So for example, if I have 3, I have 8, 6, 11, and I have 1, and I have 14, and finally I have 20 and 2. Now, how do I sort this? If you don't sort numerically, what it's going to do is it's just going to find a number. So this is going to give you a result like that. It's going to say 1, 11, 2, 20, 3, and 6. That is obviously wrong, right? This is not what we want. Oh, wait, we missed out 14. So we have 14 here. But this is obviously wrong. We don't want this. What we want is we want to have 1, 2, 3, 6, 11, 14, 20. This is what we want. So sort numerically allows us to just specify exactly that. So we get to sort, but it makes numerical sense to us. Let's see an example. You can just do a sort -n, and you can have red sample.csv, and that would just sort by numerical sense. So it would take 365, 367, it wouldn't, and then there's 581587. Well, in this case here, it doesn't really do anything different, but in the situation that I just described above, it would make a difference. And let's combine the -n and the -k option together to show you a full example. So let's take a look at the header here. Now, what if I want to just take invoice number, stock code, and description, and I want to maybe sort by the invoice number? So how would I do that? So I could say something like cut, and in this case here, I want to cut the first 3 field. So I need to specify a delimiter. So I want to say delimiter by comma, and then fill, I want to say 1 to 3. So you can have a space, you can have just all of them together, and say online retail.csv. And once I've cut the first 3, so I have the invoice number, stock code, and description, what would I like to do next? Well, what I like to do next is I like to just sort them by, let's say, the first one or the stock code, up to you. But let's say the first one, right? So I can just say sort and just say -k, which say, okay, I want to take the first column, and I can say -1. I can say sort k1. But in this case here, because this is numeric, I actually want it to sort numerically. I'm going to add an and here, and then let's go ahead and just print out the whole thing, head, and let's take a look at it for 10 rows. It will try to sort by the first one. Actually, what we need to do instead is we also need to go in here to this sort, and we also need to specify that the delimiter, in this case here, we pass a comma. So what this would say is the delimiter is a comma, and that would be helpful if we want to sort, let's say, the third column. Now the third column is not a number, so let's take that away, and so we just have -3. So we want to sort by this column, the third column, and we want to say -t because we want to separate it by comma. Press enter, and this is now what we get. So it has all the empty fields. If you want to take the last few rows, we're gonna see some interesting stuff. But yep, we see G, G, G. So -k3 is saying that, okay, sort them by this column, the last column. And in this last column, by the way, it says they are not numeric. So I don't actually have to put an N option there. If you put an N option, now you specify that to be a number. So you see the numbers are all like messed up here, right? They're all different. So if they're not a number, if they're not supposed to be a number, don't want to put the -n. So let's take away the -n. This is how we sort, and now we see this. So all of them from A to Z. So it starts from all the spaces, and then from the spaces it goes to all the numbers, and then it goes to capital A to Z, and then finally it ends here. Okay, so if you want to go back to sorting on the first row, you can do that, and I guess you can put an N here. That's just gonna go back to sorting on the first row, and now these are all different again. So wrongly marked, red, bandy, and stuff. So I'll say if you're very new to all of this, try and practice the cut and sort command a couple more times, ideally on CSV datasets that are sitting on your computer somewhere. Because once you get used to it, it's really quite intuitive, and it's an extra tool that you add to your data pre-processing, preparation, and data cleansing routine. So when you're ready, you can move on to uniq. And so let me add some comments in a note, and we're gonna talk about uniq now. And uniq does what it says on the tin. It filters out repeated lines in a file. So let's see some example. Suppose your boss gives you a file and asks you to find how many unique rows are there. You may be able to find out even without opening R and Python. So you've seen how I do this, right? That would just give you this. If you try and do something like instead of cat, you say sort -u, you get this number. So you would expect that if I run uniq here, let me just write the code out first and explain that later. So if I say cat online retail and I pipe that, instead of word count, I'm going to pipe that to uniq, and then I'm going to pipe that to word count. If I run this, you would expect that I should get about the same amount as this, 536642, because this is doing the same thing. Sort, this is a -u option. -u basically says deduplicate the whole file. Any duplicates, remove them, and then sort them. But in this case here, I'm just saying uniq here. So you should do the same thing. Let me run that and see if it's the same. Oh, it's not the same. So what is the difference here? What is the difference between sort -u and a uniq? Why does the numbers disagree here? And first thing first, and this may surprise you, even if you're quite familiar with the shell commands and you use them quite a while, you probably did not know about this. But uniq is not able to detect the duplicate lines unless they are adjacent to each other. So in this case here, if I have something like Samuel, and I have Samuel again, then I have John, and finally I have Andy. All right, uniq is going to be able to detect them because they're adjacent to each other. But if I move this, and I go to one extra line, and I paste that, would he still detect that? No. So uniq is going to count on the fact that the duplicates are going to be adjacent to each other in order for it to count. And so in this case here, the content in the file must be sorted before you run uniq. Or you can simply just use the sort-u, which is what you see up here. Alright, so let me show you what I mean by that. If you try and take this and you sort them, and then you run uniq, now you get the same numbers. So 536642, 536642. You need to sort them so that when you sort them, now Samuel and Samuel is going to place next to each other, and then you find a uniq. So it's kind of one extra step here, and you would be better off to just use sort-u. And the reason I talk about this is I feel like all shell programming lessons should start with this caveat. You should start with this disclaimer about uniq before they teach you about uniq, because I've seen people who have programmed in a shell for quite a while and then use uniq thinking that they're going to get a unique list of order values, and then be surprised when the program doesn't work as intended, right? So I want to make sure that that is the thing that is clear to you first, right? And speaking of like shell scripting and stuff like that, when you get more familiar with it, you start to write scripts. We'll probably cover that in a future video, but right now, let me throw in a bonus here. Suppose you want to find how many lines of duplicates are there, again, without using R or Python. How would you go about doing that, right? So in other words, perform this simple arithmetic programmatically, but only using shells without using any kind of R, Python, or any extra tools here. How would you do that? How would you find a difference between this and this? How would you find a difference between this and this? So there are at least one or two ways to solve this problem. I'm sure that folks in the comment section is going to tell me other ways to achieve the same thing. But let's go ahead and use what we've learned before. Remember we learned about the shell commands, and at the very beginning we talked about the environment variables, and you've seen an example of that. So we can now go ahead and just create an environment variable. So I'm going to go ahead and create value1, no spaces. That's going to just be this command. So I'm going to just say cat online retail, right? So cat so that's the old value, right? That's the original value. That's the original file itself. This is how many rows there are. So let's run that. And then I'm also going to create a second one. So I'm going to say while2. In here, it's up to you. You could do this cat online retail sort uniq, or you can just do this sort-u. It's up to you. But I'm just going to say cat. But since we're learning about uniq, we might as well just use the unique one. So we're going to say sort, and after sort, uniq, and finally, wordcount. So we have value1, we have value2. And to find the difference between them, and you can just print out value1 if you want to. Val1, like this. So your boss question here is that how many duplicates rows are there actually, right? So the difference is this and this. How would you minus them without using R or Python? So arithmetic can be done. I know of at least two ways to do that. They can be done with this. Maybe the first one is to just use a $ followed by two parentheses like this. All right. So let me just echo that out. Okay, echo, and I could say $ and then followed by this. And then in here, you could just say value1 minus value2. So you can say value1 minus value2, just like this. You could, if you want to, you could add the $ here as well to make it clear that these are variables, but they're not. They're optional. You don't have that. You don't need to have them. Then you can just have the whole thing as a string, just like that, right? So this will work if you just remove them and just have them like that. That will also work. So as long as you have a $ and then two brackets, run them, and you get the results 5268. Another way you can do this is to use the expression. So you can say expr, and you can say $value1 minus value2. So you can do that as well, and you get the same value. So this is just a bonus here. You don't have to learn them if you want to, but since we already seen the examples, so let's add the comment in here. Perform arithmetic, and that's kind of it. If you want to, you could just go ahead and give some examples. You can have like old value or new value minus old value, and you don't have to have the $ anymore. But if you want to, you could have that as well, right? Let's go back to uniq. So general rule of thumb, if you have any doubt at all, usually perform a sort before you try to do uniq, right? Perform a sort, pipe into uniq. If you just wanted to count the number of unique values, you could just stick to sort-u. This would be so much cleaner and easier than to have to do this, right? But that's up to you. But if you could use sort-u to solve all these problems, why do you need to learn uniq at all? Why am I wasting your time? And so the way I look at uniq is I don't actually think of it as unique. I think of them more like a count table. So I really use them usually with a -c. So when you call uniq, you can pass in a C, and the C is going to give you a count table. So I actually use the -C option with uniq, and think of uniq more like a count table, more like a frequency table. If you're used to R programming or Python programming, you have a frequency table or you have a tabulate function. That's kind of how I use uniq. So to show you an example, let me just go ahead and let's print out the first few rows of data first, right? So this is it. I want to tabulate the items sold in the transactions within this time period. So how would I do that? So for example, this is the, so to start with, I have first, second, third. This is the third column. So let's go ahead and just say cut -d separated by comma -f, take the third column, online retail.csv, and then what do I have? I want to say take that and sort them. In this case, it's not going to be by number, so I don't care about the number. So just going to have a pipe, and I'm going to have unique now, and I'm going to say just give me the count. So putting a count makes this unique more, it gives you the number of counts for each of these unique items, so it gives you a count table in a way. So let me see that, and I want to just maybe print the first 20 rows of data. So let's do that. There you go. So it says, well, there are a lot of items with no description. Then there are 47 with one, maybe this is a encoding error. They didn't, maybe they were typing some sort of characters that wasn't recognized or something else, maybe a different language. And how many of them are there in our transaction? 327. So they appear in 327 of those. Oh. So they appear in 327 lines of our CSV. And what about this one? 12 pencil steel tube woodland, or 256. So this is how I typically use the unique command. I use it more like a tabulate. If you're used to R Python programming, you know what I mean. Just printing out the count table, frequency table, and that's how I use it. So C gives you the counts of each unique item in your data set, right? Now let's work on some scenarios. Okay, scenario number 1. I want you to tabulate and return the top 20 countries or destination countries along with the counts. Okay, so this is a big hint. We just learned that. You should know how to do that already. It's a very big hint here when you see like tabulate and return with along with the counts. You should know what to do. So try that. Then the second scenario is, if you're also trying to learn a little bit of Veeam, you want to center that in your screen, you just have to say GG. So GG, just center the screen, right? And let me increase the space here. And the second scenario, export a CSV and name it, I don't know, high value transaction, I guess, high value transactions, all right, .csv, containing the invoice ID, unit price, and customer ID of the top 30 most expensive unit price item of online retail. I mean, all of these are online retail, so you should know what to do, right? So I want you to take a look at the online retail.csv, and I want to return the invoice ID, the unit price, and the customer ID of the top 30 most expensive unit price items. So I don't care about the quantity, I don't care about anything else, just the unit price itself. So this is also a fairly common scenario as a data analytics working in e-commerce. For example, you want to say, hey, the 30 most expensive items on Tokopedia, on Gojek, on Amazon, on eBay, right? So what would the top 30 most expensive items be? Export them and also show me the invoice ID and show me the unit price. So I want to have all of them. If the most expensive item is a notebook that is priced at 55,000, I want to see every transaction that includes that notebook. So don't try and do something like unique or anything like that. If the most expensive item is a MacBook Pro, then just print out all transactions involving that MacBook Pro. So just look at the unit price of the items and then find the 30 most expensive one. And I'll give you the last scenario. This is kind of difficult, but this is something that you can try optionally. Maybe try and Google it and stuff. But I'll give you the answer anyway, right? Because I don't have time to go into even more content. I want to just stick to what I've taught you here, which is kind of the WC, the head, the tail, the cut, the sort, and the unique. I don't want to go into anything else beyond that. Let me center the screen again. But here I want to say, like, okay, find the 5 most expensive items and optionally sum them. Right? This is gonna be, it looks easy. Find the 5 most expensive items. How difficult can that be? But optionally sum them up. Okay, that's the difficult part, right? How do you sum them up? I haven't actually taught you that yet, but I want to see how resourceful are you. Maybe go online, search it out, find it out on your own, right? I'm going to delete the word here, delete character, delete word. All right. So those are the 3 scenarios. If you want to pause the video right now and try them using what you've learned, all these scenarios can be answered using things that you learned, except maybe the last one, the sum them up part. But even then, maybe you can find some ways to be resourceful about how to approach that problem and come up with something nice, and you can leave them in the comments, and you know, I'll be really proud of you. I'll give you a shout out in the next video. Not that it matters because I have so little followers anyway. So anyway, first one, tabulate and return the top 20 destination countries along with the counts. How would you do that? So I like to just print out the head again. So there's invoice number, stock code, description, quantity. What do I need here? Well, obviously I care about the country more than anything else. I only need the last country, in fact. So I could go ahead and say cot-d. What is the delimiter here? The comma. It's a comma separated values. So I'm just gonna say -d, and I'm gonna take the field. Which field number do I want? The last field, -8. And then from there, pass in the name of the CSV. So there's gonna be online retail.csv. And then what do I want to do next? I want to sort them. Do I need to sort by any unique values of the country? No, because I just want to actually sort them, and then from there I just want to count the unique with the table. So I want to say sort, and then I want to say unique-c, that would just give me the count table. If you were to just run this, you will see that you get this, which is not bad. It comes quite close to what you want, but you want to return only the top 20 destination countries. So this is the requirement, top 20, and so this is still not really what you want yet. What do you want to do now? You want to sort by this again, right? But you want this to be in descending order. So you want to say something like sort-r, and then you can say head-n20. Now I'm going to run this because I know this is going to be a problem. The first time I run this in a class demo, I told my students to find out where this is wrong. You know, if let's say this is the command, what could go wrong here? Where is something is missing here? Can you pause the video and find out what is missing here? Where is the mistake in here? Now the mistake is that if these are numbers, you want to put in an n as well. You want to put -r-n, or you can just combine them into be rn or nr. So n is going to sort by number numerically. That is going to make sure that 11 doesn't come before 2. So 1 goes to 11, and then 2, 3, and then 35, and then 4. It's not going to make that kind of sorting. It's going to make sure that it makes numerical sense. So 1, 2, 3, and then 11, and then 20, and then 21. So you want to put an n here. So if you can spot that mistake earlier, well done. You got a pretty good grasp of what you're learning here. But if you can't, it's okay. You're just starting out. So let's run that. And this is what I want, right? So that's the United Kingdom, Germany, France, and all of this. So that's the solution for scenario number 1. Did you get it? I hope you did. So scenario number 2, export CSV name high value transactions containing the invoice ID, unit price, and customer ID. So again, we need to do some sort of cut again because we need to find exactly these 3 columns. So let's go ahead and just print out the head again. So there's invoice number, stock code, description, quantity, invoice. All right, cool. What do we need? Invoice ID. So that's the number. First one, unit price. So 6, and customer ID, that's 7. So 167. So I know that I will have some sort of like comma, delimiter, fill 1, 6, and 7. And then what do I have? The name of the dataset, online retail.csv. And I want to take the top 30 most expensive unit price item. So the most expensive unit price item, that's the number 6. That's the column number 6. So if I were to just print that out and I said head-n10, that's going to give me 1, 2, 3. It's still not meeting my requirement. I want to contain the most expensive unit price item. So that's the second column out of these 3 columns. That's the second field. So how do I do this? I want to add an extra thing here to say sort, and I want to sort by what? I want to sort by take the column. Which column? Second column. So you can do this, or you can just stick them together. And not only do I want to take them this way, I also want to take the top 30 most expensive one. So it makes sense that I want the unique items. And because we learned that these are all numeric, so I want to sort them by numeric. So you can have -nu. Since I pass in the -k2, it's going to say take the second field. But if you pass a second field, then what do you need to do? You need to tell it what to separate that by. So the separator, right? So let's put in a separator and put -t, and we put comma. Then finally, we pipe them to head. But in this case here, because we didn't reverse the order, we want to take the tail. So this is acceptable. If you run that, you're going to get the values 400 all the way to 38,970. So this is interesting. There is something that we sold for 38,970. There's something we sold for 6,930, and then there's something we sold for 2,500. All right, cool. Another option is to just use the head, but then what would you need to do here? What would you need to change here in order to make the head work? Again, you want to, if you did not try to complete this exercise, this is your last chance. What do I need to change here? I'll give you a hint. It's within here. What do I need to change here in order for this to work? So I don't want to change the head. I still want a head, but what do I need to change here? I need to sort of do what? If I run this, it's going to give me the top 10 cheapest. So what do I need to do? I need to reverse the order. Where do I do that? You can pass R in here. You can pass R in here. Anyway. All right, so let me just pass R there and run that. And now I still have the same value. So I'm still going to see the 38,000, 6,930. So these are the top 30 most expensive unit price items containing the invoice ID. But the question is to export this into a CSV. So you want to take this and you want to use the redirection and give it a name called highvtransactions.csv. And that's how you do it. Finally, the last question, find the 5 most expensive items, optionally sum them up. We know already that the unit price is number 6. We know that from here. The earlier exercise is somewhat related to that. So I can say something like cut D -F, but I'm only going to take the 6th item. And then I'm going to say online retail.csv. And I would sort them. But I know that this is unit price because I'm looking at most expensive items. So obviously it's unit price. I want to sort them by numeric. And then what do I want to do next? If I just print out the top 5 most expensive items, I could put -R and I can say hit and 5. That would give me the top 5. Or you could just remove the R but then put a tail, right? Now these are the top 5 most expensive items. Optionally sum them up. How would you do that? So this is kind of a teaser to the next video, but I don't know. I mean, if there's interest in the video, if people are looking at it, watching it, there's enough people watching it, then it tells me that there's an interest in this. Then I'll maybe do a follow-up on, maybe an hour-long video on how to do that. But if you want to go ahead and try that, then it's fine to close out the video and go and try it on your own. How do you sum these 5 values up there? You could use one of those things that you learned earlier, which is to use the plus operator, the express, expr, expression. You can do that. I want to show you an extra, sort of a bonus, is that I can also take this and I can say something like paste. I haven't taught you what paste is yet, but paste has this S option that will serialize everything into a single line. So it will all go into a single line. And then what do I do next? I want to say, well, you paste them all into a single line. I also want to put a delimiter here. So the delimiter is going to be something like D, and I'm going to say plus. So here I'm saying the delimiter should of all of them. So instead of actually having them as spaces, I want to actually have them as plus. So this is going to be this plus this plus this. So let me show you what I mean by that. Run that. Now I have the plus. Then all that is left is to just use the basic calculator, built into shell as well. And to do that, you say BC. BC stands for basic calculator. So let me, since I talked about that already, might as well do that in here. Like this, right? So let's go back up here and press up to go back to your previous command, and then just pipe a BC like this, run it, and there you have it. So you have the 5 most expensive items in your online commerce shop, sum up. So if you sell the top 5 most expensive items in your e-commerce shop, you will be netting 103,000 if you sell 1 unit of each one of those, of the 5 unit. And I think I'll leave this here because I suspect my time is up. But if you want some challenge, try and see if there are more efficient ways to solve these, the 3 scenarios that I gave you here. And leave them in the comment section if you manage to come up with something clever, alright? And they should mostly be one-liner shell commands. And try to take a closer look also at the paste command and the BC command. Try and run some practice there. I'll cover more of that maybe in the future episodes. Remember to share this video to another fellow data scientist who is lacking in their shell skills. If there's enough interest, we get to do more episodes of this in the future. And maybe in those episodes, we get to learn some new tricks that would add a new dimension to your data preparation, cleansing, exploratory process. I hope you enjoyed the video. Share with your friend. I'll catch you later.